Expressing concentrations is extremely important in measurements. If you think of medicine and all the different things that they measure on you to make sure you're in spec, it's really important to be both precise and accurate. In our class, we are going to share with you 4 different kinds of solution concentration measurements. The first one is mass percent. And here it says if I have a 36 weight percent solution of hydrochloric acid, how much water do I have? Well, 36 weight percent is the same thing as saying 36 grams of HCl in 100 grams of solution. See, I almost wrote water. That's what people often do. So if I have 100 grams of solution and 36 grams of that is HCl, what I have left are 63 grams of water. Now you may use that as we do some of the other problems, so we wanted to start out by saying what is a mass percent. The second one, it is tricky. It is and it isn't. So I'm going to show you something that they have in your textbook. Maybe you've seen it, maybe you've not. It says we have 0.0079 grams of strontium 2+ in kilograms of water. The way to look at this one is, if I can turn this into milligrams per liter, I will have ppm. So when I look at 0.0079 grams of SR2+, that is the same thing as saying 7.5 milligrams. If I look at a kilogram of water, that is the same thing as saying a liter of water. So very simply put, ppm is equal to 7.9 milligrams of SR2+ divided by a kilogram or a liter of solution, and that comes out to be 7.9 ppm SR2+. Again, it's the units that you have to think about in order to solve this problem. Third problem is one we've traditionally done here in 1220, and it introduces this new measurement called molality. Why do we need it? Well, molality does not vary with temperature. So what I have here is if I have a 1 molar carbon tetrachloride solution, it has a volume of 1 liter. If I have a 1 molal solution of CCl4, it has a volume of only 630 mLs. So you really need to know how much you have of something. In the real world, things are done on a much larger scale. Often a truck is driven onto a balance and the weight of the material is measured in that way. So we aren't going to use trucks. We're just going to say, what is the molality of antifreeze? Antifreeze is really ethylene glycol, and you notice it says 23.9% ethylene glycol in water. So you know from the mass percent, okay, you know that will be 23.9 grams of ethylene glycol. And we would have, in terms of the number of moles, we would say 1 mole of ethylene glycol weighs 62.07 grams of ethylene glycol, and we would come up with 0.385 moles of ethylene glycol. Why did I do that? Well, because molality in the numerator wants the moles of solute. How many kilograms of solvent do I have? Well, if I had 100 grams of solution, and I knew there were 23.9 grams of ethylene glycol, it would tell me there are 76.1 grams of water. That is my, I hate to draw an arrow, but I will, that is my amount of solvent. I don't have the units for solvent proper, but I'll write it this way. My molality will be 0.385 moles of ethylene glycol divided by 0.061 kilograms of water. When I crunch those numbers through, I come up with 5.06 molal. We're going to be talking about colligative properties, and that's where we use molality and not molarity. Take a moment to think your way through this. Students tend to struggle. That's the only reason that I'm pausing and mentioning it. The next calculation asks about the molarity of antifreeze. And the reason we're doing this in class is to show you the method to do it. If we remember from Chemistry 1210, it is the moles of solute divided by the liters of solution. What you do to solve this problem is assume 1 liter of solution. And that tells you that 1045 grams per ml. We know that there are 10 to the third mLs for every liter of solution, and that will give us 1045 grams per liter of solution. And again, I'm doing this in class because students have often asked, why are you doing these things? It's the method that we use. So then, another strange thing that happens is we know we have 0.385 moles of ethylene glycol. That's from the previous problem. We know that it's sitting in 100 grams of solution. By knowing the density, 1045 grams of solution, 1045 grams of solution, for every liter of solution, we come up with 4.02 moles per liter, which is 4.02 molar. Again, students have asked many questions about this, so I just want to say to you, this may not be thought of by you. There may be another way to do it, but this is how we go from molality to molarity, okay? And the last one is fresh. The last one talks about nitric acid, and it wants to know what is the molality. You are given the molarity, you are given the density. And what I did is I usually just sketch these things out, okay? It says find the grams of HNO3 nitric acid. Well, if you know you have 15.9 moles, how do I know that? From the molarity. And you learn that it weighs 63.01 grams of HNO3 for every mole of HNO3. You'll come up with 1,002 grams of HNO3. So now, what are you going to do next? Well, you're going to assume, once again, 1 liter of solution. So if you have a density of 1.42 grams per ml, and there are 10 to the third milliliters for every liter, it's going to tell you that you have 1420 grams of solution. So here's where I usually draw a picture. I say, okay, imagine you have a beaker. The beaker is sitting on a balance, and it weighs 1420 grams. Sitting in that beaker, you have HNO3 and you have water. Since they're both sitting there, we know that we have a measurement for our grams of HNO3. We know we have a measurement for our grams of solution. So that's where I put this little equation down, and all you need to do at this point, but it is hard. I'm not going to say it's easy, okay? It is hard. You just say that my grams of water are going to be equal to my grams of solution minus my grams of HNO3. And putting in the numbers, I have 1420 grams of solution. I have 1002 grams of HNO3, and that will give me a grand total of 418 grams of water. Again, I put everything down because I know if I just put the numbers down, everybody gets lost. So realize it is actually a 4-step process. And what is the 4th step? Well, I take my moles of HNO3, which were 15.9 moles. I take my water and I turn it into kilograms of water, and I come up with a molality of 38.0 molal HNO3. All of these are fair game for an exam. That's why I have to make sure I spell everything out. We tend to work with very, very, very dilute aqueous solutions, so often our molality and our molarity are going to be the same. Again, these were 4 different types of calculations. The only way you're going to learn them is by practicing and thinking your way through. There is no way to really memorize. I don't know, it's that thing I called insight. You know, there's facts, there's methods, and those lead you to insight. We're building on things we did in 1210 and we're taking it to the next step.